Hello and welcome to our fifth webinar, to our fifth ASQF Net Wekk, and the first webinar, that's the right way. I'm very happy that everyone dialed in for this free talk of our ASQF Net Wekk, and we have a lot of talks today and still on Friday, and you still have the opportunity to dial in even on short notice. So just check our website if there's still something nice you want to hear about. And today is our focus on testing. And at this point, a big thank you to our sponsor of today, Trimitis GFB IT Consulting. Thanks for that. Without our supporters and sponsors, we couldn't do this network. So we are very thankful for everyone who is helping, even money-wise or with their knowledge, like Henri today. So I welcome Henri. Some of you already know him from talks before at the ASQF, so maybe he's already known by you. Yeah, I'm very happy that he is talking today about the future of AI test automation, human and robots. So I can only say, Henri, would you like to introduce yourself a little bit for the people who don't know you yet?
Hello, everybody. As said, my name is Henri, and I'm from a company called Copado. I used to be in a company called Sentinel, and we do a lot of test automation for every single platform that there is, mainly based on web and on other platforms as well. And I'm at the role of a product evangelist, so I look into a research project, look into the future, and this talk is also going to be a little bit about the future and where we are going and what I think might happen in the testing space. Not too much about specific technology, but more about where we are going in the bigger picture.
Okay, great. Thanks, Henri. Maybe you can share your screen now. I hand over. Awesome. Great. So enjoy, guys. And oh yeah, one more thing. If there are any questions about the topics, let's raise your hand digital kind of way, and then I can unmute the people to speak to Henri or use the question panel. And so it's your turn, Henri.
Yeah, I have the question panel up and all of that up. And if you have any questions, you can interrupt me at any point. And I actually like if we could get some kind of dynamic going and getting those interruptions in there as well. So the topic for today is future of test automation, humans versus robots, and a little bit of diving into what's happening in maybe in the programming and software scene, and what's also happening in the testing scene, and talking about where we are actually going with these. This is like a synthesis of some talks that I've previously done, and building on top of those on what I think is actually happening in many of the different testing spaces that there is. Looking at the agenda, what we're going to do in here is we're going to just shortly go through Copado, all the necessary slides that we have to do, then jumping into a little bit of low code and DevOps. What's going on with low code and DevOps now, and how is that changing testing? And talking about the future of test automation, and then talk about how the role of humans versus robots is going on. And we're going to have a QA at the end as well, and there might be a surprise at the end as well. So just quickly, what's Copado about? It's one of the largest low-code DevOps ecosystems built around Salesforce. So we have a not just testing company, but we have a DevOps solution for CI/CD on Salesforce and some of the other services as well, mainly focused on the US side of things now. I'm from the European side, and I'm from the testing side. So there's some integrations in there into testing, and I'm going to talk much about testing today as well. And the idea that we have is we have the low code angle on many of the things that we do. We don't want to talk about no code. We don't believe in hiding the actual code or hiding the actual test cases, but making it simpler and raising the abstraction level of the actual test cases to help you deliver more value faster in there to our clients and to everybody else as well. So going into the actual topic on what we are going to talk about is mostly about low code testing and DevOps and the future of human interaction with code. Jumping back into the actual history a little bit on talking about how we've actually been developing code and what kind of tools we've been using. Looking back at this is To actually test software and actually develop software, you need faster tools to actually test with the same pace as development. Looking back at software development, we started actually developing software back in the day when software development was pretty much hardware development. You had to build up your own microprocessors. You had to take a soldering iron and get components from a store to do it, read instructions from a magazine, and build up the actual hardware to basically run a computer or software process in there. I haven't lived through this age where you actually needed those parts and you actually build up your own stuff. But I've started programming back in the day with Commodore and others, starting the program with machine language and all of these, like where you had to handle all memory places and all of that by yourself. And even that was a raising of abstraction level from the hardware to the actual machine language that help you be much more productive. And the funny thing is that back then, of course, then C++ and C came in as higher level languages. Basically what we probably now say low code languages really simplify a lot of things, abstract away a lot of things from the actual programming. You don't have to handle memory. You don't have to, well, you kind of have to handle memory, but you don't have to handle the actual memory addresses. You have a lot of visual construction on top of that you can do in C++. In C, you have to do something more specific and kind of like slowly building up this automation inside of these programming languages, which I think is interesting. That's what we are getting. We're basically building a lot of automation and a lot of intelligence inside of these programming languages in a sense. On top of these, we build up Python or some of the scripting languages, JavaScript and the others, which then take up a lot more of the burden as well from the developers, or not just automating or automating even more and doing an even higher abstraction level as well on going into, you don't have to handle about variable types or strong typing or anything like that. We'll handle it for you. And I think this is the kind of path that we're taking currently. We're currently raising the abstraction level of programming languages even higher. And now I think we are in this low code step that we're talking about. A lot of code generators, well, code generators have always been present in the industry from the 80s and onwards, I guess. But now it's becoming more and more prevalent with a lot of companies building website generators and website this and that will build you the code on drag and drop editors. And I guess if any of you have actually had to test some of that code that those generators build, or test the websites that have been built with some of these like builders, it's not pretty on the code side. That's what's actually going on there. But I think that's going to change, and that's progressing still. And we're building on top of that, making it more and more accessible to build stuff with the programming languages is going to happen, and more of that stuff will get abstracted away. So what I think we're going to end up in the future is this kind of like human-like interaction with machines and all of that. The actual computers and all of that will actually interpret what you're saying or what you want to do with this and build up the software behind that. And then the question becomes, where should we focus on testing? If nearly all of the code is auto-generated by some machine or some automation, what should we actually test? And that's why I like to bring up the testing pyramid, because this is typically a good conversation starter about this. And please just interrupt me at any point if you have anything to say about this or any of the other parts in there as well. On the bottom, I don't know how many of you, probably many of you know the testing pyramid and how it works, on how we layer up different kinds of testing to build up a really good confidence that our software actually works. In the bottom, we have reviews, just reviewing code, just reading through all of it. That was pretty much also, if you look at this, it's kind of like looking at the history and complexity of software as well. In the bottom, you have reviews, and if you had small software units, you could easily read through all of the code and quickly verify that it's actually doing what you think it's doing, and based on that, be quite confident on that you're getting the right thing done. But when software grows more complex, you're starting to need more and more higher levels of abstraction in testing as well. So you have static tests, testing out single functions in your actual program to check out that, for example, a calculator function works, or inputting a credit card number in a web store works. These then get bundled into units, depending, of course, on your organization. This typically happens, and when the complexity grows, you start splitting up your code base into units of a sensible size, and typically through Conway's law, You typically do it in a way that reflects your organization, not maybe the optimal architecture, but that's how it happens. You have unit tests, for example, in a web store. You might have the store part where you can actually scroll through products. Then you'd have the shopping cart, and you'd have the payments module. Test out all of these separately to figure out that they actually do what they should be doing, and then communicate through that testing to other people as well. Hey, our systems actually work, so you can actually use the APIs and other things there. And then again, raising the abstraction level of going from that on testing out the single units to integrating these units together to see that you can actually pass the contents of a shopping cart to the payments module to actually get the right pricing and right credit card information in there and going. Let me just close that Slack so that doesn't bother us during the and kind of like what's happening is we're building up abstraction levels on top of this test. We are not testing out single lines of code, we are testing functionality. And of course, this is the core and acceptance test that we are testing, not typically the actual code that's running behind, but we are testing that we can actually go into the web store, we can actually put in stuff into our shopping cart, we can then buy it, and we'll actually get shipping information out there. And in the same way, we build up abstraction levels towards the top of the pyramid that's happening in here. And this is the kind of like effect that actually, looking at the arrows that I have in here, typically building up these kind of abstraction systems are a bit more pricey, a bit more complex on building acceptance tests than just doing static reviews. Static reviews is just reading the code. Doing a single acceptance test is typically more complex than doing a single static test or single unit test. There are exceptions, of course, but that's typically how it goes. And it's typically a little bit pricier as well. But on the other hand, you need a lot less acceptance tests to actually run that test and get the same kind of result on same kind of coverage of the actual functionality of what's going. You won't be getting code coverage, but you will be getting functional coverage of your actual program quite fast with acceptance tests. And this combined with the fact that we are going to start generating a lot of the code based on a lot of builders and a lot of low code solutions or no code solutions. That the question becomes, what should we actually test in here? Should we still focus a lot on static tests and reviews if the code is built by automation or built by these kind of builders or others? Where should we focus on testing? And I'm going to talk a little bit about that angle in the presentation now. And all of this becomes pretty much synonymous with DevOps. And how do we deliver software fast? That's the goal of all of these, like raising the abstraction level. We want to provide value fast. So what ends up happening is we can have the 3 pillars in there that we typically have in DevOps. The idea of DevOps is reducing waste and getting value to the customers quickly and seeing that it actually works. For example, a typical use case in some of the like more traditional industry might be that I develop a feature. We have a big company. We have a release schedule of 2 times a year, so half a year between releases. I might make a feature which takes me 2 hours to make. That will go through testing, and then it will just wait there in the backlog to be deployed in the next yearly or half a yearly release. And that's a lot of wasted time on getting that feature in there. Then after half a year, that feature gets deployed to customers, and then we actually realize that it's not the proper way to do it, and we want to change it. It's not in my active memory anymore of what's actually happening and what did I actually even do with that feature back then. So getting back into that flow on actually fixing it and all of that is not too good. And that's why I talk a lot about that with DevOps. You want to minimize waste, of course. The 3 pillars that enable you to do that is proper flow, feedback, and continuous learning on how to do that. Looking at these, we talked a lot about flow. And I think flow is a lot about tooling, so you have the most efficient tooling that you can. So you don't want to develop web pages with assembly. That doesn't make sense, even though you can do it with web assembly nowadays. But you want to take the right level of abstraction in there. You don't really need to know anything, or you even cannot know too much about the processor architecture of the actual web user that's using your website, and you shouldn't care. That's been abstracted away from you. That easily do it. And then looking at the kind of oh, my slides are in the wrong order. Let me adjust that. Am I missing a slide? Yeah, I'm missing a slide. Well, yeah. But the idea of getting that testing feedback from there, from the different parts, I had a slide where I went through all of the different phases of testing in there, and what kind of testing do you have in there, but that's somehow missing on the feedback slide. I have to fix that. Is the idea that if you go through the cycle of testing, and we can actually use this picture as a little bit of a shorthand from what I was supposed to have in there, is that typically reviews and that kind of stuff is automated. You want to make a stack of tests which try to make them fail as fast as possible to get that feedback cycle going, so you can actually get the feature either failing as fast as possible and then get the feedback to developers back as fast as possible. Typically, reviews are quite fast, and they're maybe even integrated into your IDE, so you're constantly doing them. And this is also something that's happening in a lot of places, that this technology to do quality checking and testing is actually integrated so deeply into the process as well, that you're actually already doing testing and linting inside of your actual IDE, like VS Code, using your company code quality standards and that kind of stuff, so that you get to immediate feedback. Then you want to prioritize your static test and unit test in a way that you run the tests which are most likely to fail first. So you don't have to wait over the weekend, or you don't have to wait for a long time to get that feedback on what's actually going wrong with your testing, and going from simple cases to different, bigger and bigger cases. And for example, with static and unit tests, you shouldn't run unit tests that are related to other parts of the software that you didn't touch. You only want to initially run those tests that touch the parts that you have. And this puts also a lot of weight on the actual system that prioritizes your testing or handles your testing, not just writing the test cases, but what kind of a system actually prioritizes what's happening in there, and what's the testing going to happen on the other side as well. And on top of that, you want to start running acceptance tests, so you know the actual flow or the client flow isn't really too impeded in there and what's going on in there. And going back into this, what we actually want to do to enable that is getting the flow going with low code. And as I said, a lot of tooling is now going to be from the low code end. And if you look at this, like we're saying that 70% of new applications developed by enterprises will use low code or no code technologies. This is the kind of space that's happening, that programming language is being used. It's not going to be C and these low-level languages for a long time. It's going to be higher and higher abstraction level languages. And a lot of, I think one of the things is a lot of novice coders or people who are not coders will start developing actual software. And I think that's, I wouldn't say it's a problem per se, but it's a change that happens because when something's easy to do, you get a lot of it, and it becomes quite complex. And then suddenly when it's quite complex, it's difficult. And this is the kind of cycle that happens a lot in software and in other places as well, that when something becomes easier and easier, you start to get a lot more of it. And this happened a lot with initial web design and a lot of places as well, that you got a lot of web pages in there. But the key question still is pretty much what still QA faces is the problem that what did we actually want to do in the first place, and how can we make that? And this problem is still on QA and testing, and how do we now go through this stack of a lot of code and a lot of stuff happening inside of your programming organization to solve this problem that low code makes development faster, which makes people write more code and make it more complex and add a lot of levels in there. Even though the whole point is to write functional code, which actually provides some kind of value to the user and has actually a purpose, and not just something that you quickly coupled up because it was fun and what you do. That's why I talk a lot about robots and how do we want to build up the future of test automation. I don't think the biggest developments in test automation will happen in the actual test scripts per se. They're going to happen around test scripts and around that space. And we're going to walk through some of the older techniques towards the newer techniques that we have and what's been happening. Just talking about data analytics and machine learning, which is the oldest tricks in the book, I'd say, or like data analytics and old school maths. Nowadays, people pretty much quite quickly say that this is AI or this is machine learning and this is this and that. But actually, still just plain old statistics are one of the most powerful tools in the test manager's arsenal that I can think of. Just doing basic statistical analysis over your whole testing history can yield a lot of interesting and useful information. And this is something that's typically nowadays been left to the manager or somebody else on just manually digging through with R or some of the other statistical environments that they're not really built into the actual testing management tools that you have. And that's why we've been thinking we pretty much trying to also solve the same problem with our company, of course, and our products. And these are the kind of problems that we really want to solve with our product, is how can we help people get that statistical analysis done automatically and get that information that you can actually use in an actionable way on your test automation to actually figure out, hey, is this test just flaky? Is this something that's never passed? Hey, what's actually going on in here that actually these tests are very different from what we used to have, and something else in there. And the second thing that we also use quite a lot is just for old semantic analysis. Very old technology, or well, all of these are like neural nets are invention of the 80s as well. So all of these are quite old. So something that we can also use is we can build models of your system-mounted tests to help systems more easily create recommendations, and as I said, build better linters in there as well. And this kind of just statistical thing that's happening is helping you out a lot, and I'm going to show you some pieces of that. But then when we are going from just basic statistics that you can get pass and fail ratios, you can get distributions, you can get interesting donkey channels, or if it's just one-time fluke, if it's an outlier, this information will help you a lot if we can make it into a nice actionable package as well. The second thing is, of course, that when we start adding this AI and ML-like features or statistical-like features in here, if we can start to deviate more and more from the actual just maths into something that's a little bit non-deterministic, technology like machine vision. That's been nowadays being used a lot in UI testing as well, to identify different UI components and identify that something's happening. This is actually starting to change the paradigm a little bit on what's actually going on with testing and what's actually going on how should we look into testing. The problems we are starting to face with testing are going to be similar to the problems that humans face. For example, this meme about how to confuse machine learning about muffins and dogs. Even I'm not 100% sure which is which on a low resolution monitor or something like that. And they're quite similar. And even us humans sometimes have trouble with these kind of stuff. And it's not deterministic. It's not always going to be the same kind of results. But the problems will be similar as to what humans face in the whole thing. And how do we get into that state as well? And this is something that we've been thinking about a lot. And how do we want to help in analyzing this, and how can we move away from the pass-fail statistics to something more complex as well in test automation, maybe even more towards analytics than just speaking about pass-fail test results. And text is quite small, but pretty much just giving this is from our system, just giving you a lot of statistical information about the test that's actually going on, and where do they fit in your median test cases? Are they similar than others? How likely these tests are going to fail? For example, here, test case 1 is likely that the test fails during the test execution, and the probability of test execution without any failures on the other hand is 1.94. So giving you this statistical information about tests and then highlighting that some of the tests are quite bad actually in their statistics, you can prioritize your maintenance efforts. You can prioritize what you're actually going to figure out, or how do you optimize that set. As one thing also that's not typically talked about too much. Actually, test maintenance is, I think, one of the biggest problems in the testing industry as well. You have big organizations who have a long history of testing, who have tens of thousands of test cases built up in their backlog or in their test repositories. And there are tests that nobody dares touch because nobody's touched them for 2 years. And nobody knows if they're critical, if there's something that can be removed, if they're testing some critical function or not, but they seem to be sometimes failing, sometimes not. Maybe we can pass the release because, well, it's always been red. It seems like now it's green for some reason, we don't know. And kind of helping identify which tests could be actually removed as well from the test test repository is super important in there to help you maintain a sensible way to test, because, well, if you're running a huge amount of tests, you're also wasting a lot of time on running those tests which don't give you actual that information on is your software doing well or not. And helping with that is something that I think just basic statistics goes a long way. And then when we can start adding a lot of other things on top of that as well. This comes to semantic models and runtime analytics, removing test maintenance with intelligence baked into the actual scripts and into the actual platform as well. So looking into this is typically what happens is tests break a lot faster than the time it took to building. So what we want to do is we want to automate manual testing. I think this COMEC is pretty much the situation that I've seen in many companies, and even I have sometimes myself, like that. Nah, I don't care. All the automatic tests have crashed, and that's normal. Nobody's had time to fix them because we've been so busy doing other things or something like that. So that happens. So the testing platform will have a bigger role in managing test quality than the tests themselves. And if we can identify these flaky and fragile tests based on that runtime analytics of the tests, like when they're running, it can help you a lot. And also, if we can raise the abstraction level of the tests themselves, bake a lot of intelligence into the scripts. I said previously that test scripts might not be the way forward, but I think there is also a little bit that we can do on that front of baking a lot of intelligence into actual test scripts as well. Can help you write more, how do you say it, less fragile tests that can adapt to small changes. As for example, web testing, you don't need to be pixel perfect, but you need to be able to do the task that's being given to you, and that's happening multiple times as well. Said by incorporating machine learning, for example, the scripting language, we can make scripts more intelligent. Then you don't even notice it. You don't even know that's happening in the background. And getting rid of, for example, I'm talking from the web testing angle. That's I think one of the most complex fields, because there's so many different web front-end technologies, so many different ways of doing shadow DOMs, interacting with the website, a lot of hacks around JavaScript, a lot of stuff that's going on in there. Getting rid of the fragile bits like selectors, which test the code and not really the human interaction, is something that's really, really important, in my opinion, to actually testing out the end user experience in there. That it doesn't really matter if I cannot find the button from the DOM if it's actually on the screen. And that's why we've been building a lot of our vision of the future is pretty much replacing a lot of hard-coded selectors with machine vision and semantic analysis of the SUT, and like doing that through those models and doing that through machine vision on finding the different buttons and actually integrating that into the test script without you even knowing. Looking at this is actually quite a complex test case for Salesforce. So what we're doing here is we are actually entering a lead. I don't know how small the screen resolution is if you can read it, but the idea being that we want to boil down the test script. This is the actual test script, not too much hidden behind the curtains or anything like that. This is the actual script that you'll be going into debug, you'll be going into change and manage when you're doing this, and analyzing this when you're changing a lot of this parts. Atomic, simple keywords hiding a lot of intelligence behind them. Click text leads. There's not a single selector in there which tells you which part of the DOM this leads text is actually part of. It's all being done by analyzing the system under test and finding the leads text from the actual user interface. And actually, there's a lot of mechanisms that we have. If you have multiple leads texts in your application, if you look at, for example, this is a example, so it might be a little bit better commented, but this is what happens when you write a lot of tests. At some point, you start not commenting too much, and it's a bad habit that happens. I think everybody of you knows that as well. Looking at the line 23. We are looking at the type text. So we want to type text into an input box, which is called phone. So we want to put in a phone number in there. And then what I said about turning code into human-like interaction as well. the fourth column that we have on the script is actually what we call an anchor, or something that's close to that phone field. So we're basically telling, in the same way that I would explain to a human, hey, can you put the phone number into the phone number field in there, which is next to the first name input box as well. So using these kind of anchors, we can quite quickly tell the software that, hey, go in here and put it somewhere that's next to it. This is a very human-like way of talking. Hey, I want you to click on the menu button that's on the top left of the screen. I want you to click on the menu button that's on the top right of the screen next to the setup button, for example. And by making this test script, by hiding a lot of intelligence behind it and making it test script seem really simple, what we can do is actually make test scripts that are easily communicatable. And I think communication with code is the number one thing, and I think the most important thing that there is. We can quite easily build up a discussion between the actually end user experts or subject matter experts in there, and you are not scared that, hey, we're actually talking about code. We're actually talking about actions on what we are actually doing in here. For example, we had one healthcare case where we don't know. I don't know. I've never used healthcare information systems, for example, never. We were talking to the nurses actually who were actually using it. Hey, it actually goes. We were asking them, hey, how does it actually go? It goes like this, and then we could quite easily write this kind of a script and ask them, hey, is this the right flow that you're typically using? And this, yes, it's actually quite easy to root. Why? This is like a script for humans as well, and that's also the one thing that you can use the same scripts in there to actually talk to humans. And I think that's the big evolution that's going to happen in end user testing and in end testing, that we want to improve that communicability of those end user tests to something like, well, there's many paths like BDD, Gherkin, a lot of other tools are doing the same thing as well. And kind of like making the test scripts and those more human, so that we can communicate with not just the testers, not just the coders, but the subject matter experts and managers and everybody else as well, and really making it much more easier to know if you're actually doing the right thing with code. And then now that we've established kind of a baseline between what's happening with statistics and what can be done with just baking in intelligence inside of the actual test scripts, what we can then do on top of that, we can do self-learning tests and self-healing AI. This is always a little bit scary. Start talking about. Gonna sneeze. No, survived. This is something that is always a little bit scary to talk about, is self-learning tests and self-healing AI. It help you with repeatable tasks, as we quite quickly come to the fact that we start overfitting, or we start doing some crazy things because the AI, we don't know what our test scripts are doing anymore, because they've been changed by AI and other places as well in so many times. Like the idea of a test is actually figure out if the system under test has changed in a way that we don't want it to change. And when we are constantly updating the SUT through DevOps and other processes, the tests are constantly breaking, as we are constantly updating the actual way that the software works. So how do we balance these two things? And if we have an automated system that always kind of like says that, hey, we are gonna automatically push in tests and automatically self-heal them into a state that actually works. Do we even know what that state is? We don't want to automatically heal anything. We want the system to give you a lot of recommendations on what's actually going on in there and what's happening, and kind of like giving you as a human tips and help on, hey, have you noticed that this test fails, and I have a recommendation that you might fix it like that, and then you can fix it with a single click of a button, again taking away from that maintenance problem. But we don't want to overfit basically our algorithms on making tests always green. That's not what we are looking to do with tests. And this is pretty much, when you think about it, we are talking about test oracles here. So they're mostly single source of truth. Typically, when you think about it, test oracles are defined as a system which can be used to reasonably measure if the software is working correctly. In the end, it's typically a person. Even though we might have a lot of academia or other around that we are going to talk about that. Automated systems can do it, but actually the test oracle at the end is a person who's done the documentation, who's done the tests. Those are kind of like subset oracles that we want to do. But we want, this is basically what we want to automate. We want to help persons, which are still the #1 oracles and what the software should actually be doing, be that a PO or somebody else, to help him easily build up a Oracle light kind of features into your test automation that, hey, is this what you thought that this would work? Which can take the partial load of people, so you don't have to always think about all those little things and all of that, on like rounding the edges in there, and help you outsource some of that responsibility from your brain to the actual system. And this is what we do normally with documentation, with tests. And now we just want to do it a little bit more faster and automated with tests. And this is something that we can, again, we've been dabbling away with this on our test end. That in our live testing environment, we can kind of do this based on semantic analysis, giving you some recommendations, not just based on text analysis, but on the structure of the page or the location of the elements. And there's a lot of stuff going on in there. We're using a couple of neural networks in there as well, and a little modeling in their background. But the basic idea being, we know our model is not perfect. We know sometimes it produces really wonky results. But if it produces nice results 95% of the time, like here, I've accidentally, for a demo case, written that, hey, I want to, in this test web store that we have t-shirts on sale. I've actually accidentally, or we've changed the web store in such a way that we used to have a shirt called Bumble the Cat, but nowadays we have Bumble the Elephant. And now the system can quite easily recommend that, hey, actually on the same place that we used to have this, we now have the Bumble the Elephant t-shirt. So you're probably meaning this, and do you want me to fix your test case to prefer the Bumble the Elephant and not Bumble the Cat? And these kind of fixes that help you, not 100% of the time, but help you quickly fix something 90% of the time, I think will also be the future in kind of letting these smart systems support your development and testing, and letting you spend more time on the actual difficult cases. Because we don't want to solve the difficult to solve cases automatically. We want to help you guys use most of your brain only on the difficult cases and not on the menial, really small, this is again one of these cases, if you know what I mean. And I think lastly, the thing that I'm getting at here through all of this automation, all this, is that the role of humans is, in my opinion, today's test oracle still, and creative decision makers. When you think about it, what we're doing when we are programming, we're actually translating ideas from our head into reality. And this is maybe not so tactile in software, but it's quite tactile in product design and other places. And it's pretty much we are willing something to existence. Pretty much everywhere, if you look around you, products have been built into existence by humans. A microphone didn't exist before somebody thought, hey, this would actually be a good idea to do something like that. A pen didn't exist before some humans decided, hey, this could be something that's interesting. So a lot of this stuff that we take for granted nowadays is just somebody's crazy idea that they decided to start formulating. And I think that's the thing that humans are best at, is our ability to imagine solutions and then express them quite well. And while we are best at creativity, we can leave the monotonous work to the robots and automate a lot of that menial work that we don't want to be spending time on, so that we free up more time to actually build up these kind of new products and stuff as well. It doesn't have to be a complex product. It might be a toaster. A toaster is a perfect example. Somebody decided, hey, I want an easier way to get toasted bread, and this might be a good idea. And then he just implemented the idea that he had on his head and started selling that idea. So I think that's the major thing that we want to focus on: the most difficult cases, the most creative cases, and all of that around that. And we want robots to be the best helping hand for you. As robots, automation, I'm using these words in a kind of like a little bit of maybe a confusing manner even. That robot is something, it might be physical, it might be software robot, something that you can interact with in a human-like way, that can help you sift through data, do monotonous tasks, and when something difficult happens, not make decisions. That I still believe that decision-making should still be left to humans, and help you in this, like in this picture, that like we can let the humans handle the "I'm not a robot" button, And we do that actually quite a lot in our automation as well. When we test some web pages, we still have this kind of prompts where some actual person has to, unfortunately, click on the "I'm not a robot" button, but I think we're getting through that as well quite soon. And the idea being that they are really good at digging through a lot of data, doing analytics for you, and then what we want them to do is abstracting away most of that information that in there that is kind of like useless for you, and helping you sift through the data and help you into it. And this is something that can be done in analytics, for example, that diving deep into a lot of issues you don't really want to see as a human. I think the best that we have, for example, here is a little bit of our dashboard. I'm just using our own software as an example, just as something that I believe that embodies a lot of the values that I believe, as this is something that we've been doing. They're not perfect, but that's what we are building, is that we want to abstract the information on the top level quite much. For example, here you have green, yellow, red abstractions. We know if we are on the green, everything is good. If we are the yellow, something's starting to go wrong. If you're in the red, we know something's wrong, and only then start reacting to that to improve that somehow. This is something that we've been doing a lot, like what we call release quality in there. For example, our release quality abstraction, it's just that release, it's a quality index that we calculate from all the test cases, all tickets, a lot of different places, and give you a changing number. I don't care if it's 54.69. I only care about the fact that it's smaller than the quality in use. So now I know, quickly looking at this dashboard, that, hey, we have to improve the quality of this next release so that it matches what we currently have in use. And I don't care if what the number is in there. I care about the delta of that number in the same way as stock indexes work as well, and others work as well. And I also care a lot about our customer happiness, but also our developer happiness. Developer happiness seems to map quite one-to-one to product quality. That's an interesting thing that we've noticed from a lot of the data. That if your developers are happy, if they like what they're doing, they produce quality code. If they're not happy, well, other things happen. So that's been an interesting kind of like tidbit that's come out of this automated analysis that we've been running on our systems, that we discovered through machine learning and discovered through classification algorithms as well. I said that these are the things that we can do nowadays and where we are going, and we can kind of from this extrapolate into the future of software intelligence breakthroughs, that what we're doing. And less is more. Abstract away as much as we can, automate as much as we can, but still leave the door open if you need to do something underneath the hood. We never want to limit the access underneath the hood. It's kind of the same situation as with cars and everything. You don't nowadays need to fix too much of your car, but you can still go ahead and fix some parts of your car if you want to, and if you need to, and if you have the know-how. But of course, that's also happening. That we have, of course, what is it called? Specialization that's happening. That the specialization, of course, gives a lot of powers in there as well. That you don't fix maybe your car yourself when the car tells you, hey, I'm actually a little bit broken. Could you take me to a professional mechanic? Maybe it could even tell you that, hey, one of the lights is broken, you could switch it like that. So we want to this kind of like supportive automation in a lot of places that we have, and I can help you in there. And we want more communicability, because that's what code in essence is. It's telling how to do things. It's an algorithm, how to do things. And when we're talking about test algorithms, we want to be able to explain what the software should be doing to humans and to the actual software system as well. So we don't want dumbed down code. We want more communicability and higher abstraction. And I think one big thing that's happening in software is, of course, non-deterministic software. And we need more than just pass or fail type of values for this. As more and more code, again, will be used by people as no code, but we'll also be including more and more neural network based algorithms and non-deterministic algorithms into our runtime environment. So there will be black swan events. There will be other kind of stuff that's happening in there, and you will not always get the same output for the same inputs in these systems. Of course, processors, we can debate about if processors are deterministic or non-deterministic, and these things will be in the run environments and will always be cloud connected. So the whole thing is quite complex and what's happening. But I don't think it's a bad thing, but it's just going to happen. And this is also the analytics and testing will travel closer together. It will help you grow too complex, and AI solutions in testing will become more and more prevalent as well. And that's what I think is what's happening in testing. We're going to focus more and more on acceptance test and integration test layers because of the human-like interaction in there as well. And because of that shift in there, I believe that we'll be outsourcing a lot of lower level testing to the tool builders and some other places as well in there as well. And somebody's messed up with my slides, and I'm missing one of the slides. Somebody's edited this. I don't like Google Slides because of this, that somebody actually steals your slides. And there was supposed to be a finishing slide. Pretty much my idea of what's going on is 3 points. Raise the abstraction level, don't dumb it down. Let AI and machine learning and statistics be helping guides for you, but still leave humans as the main testing oracles, but abstract away as much as we can. We can use test automation, we can use automation, we can use AI for a lot of menial things that you don't want to be doing, and focus on the human creativity. I think those will be my tenets for the future of software testing. Do we have any questions and answers now? Or do you have any questions? I might have answers.
Thank you very much, Henri, for the presentation. I very loved the picture of the dogs in the muffin. I was laughing quite loudly here. But beside that, it was very interesting to hear about your talk. And so guys, everyone who's listening, if you have questions, now is your chance to do so. Either you raise your hand, there's like a little hand sign beside your name. You can click that and then we can unmute you, or you write it in the panel. Before we do so, I quickly have a little introduction about our ASQF, in case you haven't heard of us, or in case it's the first time you're joining our network. So if you like our formats, we're forward to welcome you as a member at the ASQF. We have been an expert network for software testing since 25 years now, and our network includes over 1,200 members in the German-speaking areas. But as you see, we also have a lot of internationals, as Henri or Copado as members. They used to be located in Finland and now America, if I'm not wrong. And so we are also international, but mainly German speaking. And if you join us now as a member, you can get the half price of the annual feed in this year. So it's a good time to join now and to try out our network. And also we're also very happy for the people not only joining us, also participate in the ASQF. So if you like to share your knowledge within presentations, or get to our working groups to create certifications and so on, there's a lot of things you can try out in the ASQF, and we're always happy to get new people there. So that's about our network. So let's see if anyone wants to ask something. Okay, actually I find something here. Great talk. I really love the test pyramid, that is including static tests and reviews as the most basic test, even below unit testing. That's how it should be, because it's very the basic. Okay, that's not a question, it's just like a comment, but nice to hear that the people are agreeing with you. Anything?
It's a good comment. It's a good comment also on the fact that not many people think about reviews as being tests, and also on the other end, not many people think about analytics being testing, but they all have the same goal on providing better quality code.
Yeah, and I think the pyramid is always quite often difficult build up. So it's interesting how everyone is like doing it. So great that we that our audience agree with that. Anything else? Anyone else want to comment something or have questions for Henri? It's now your chance. So we have something coming in. Thank you for the great talk. Do you think that the shift to write scripts as you would like to, do you think that the shift to write scripts as you would talk with human will raise the trust to robots and AI?
A good question. I think properly implemented they will, as they will help the communication gap between automated systems and humans. And that's always been the problem, that a lot of people are scared about the stuff that they don't understand. And if you make stuff easier to understand, it's a lot easier to communicate about that as well. And we've noticed that just with making test scripts simpler, that people are then more trusty of what the automation is actually doing, because they understand what it's doing as well. So I'm guessing it will have a positive impact. I don't know how big of a positive impact it will have, but I'm pretty sure it will have a positive impact.
Okay, great. So there's a lot of comments coming in that it was a great talk, and thanks for the meaningful presentation, Henri. So audience was quite pleased by your presentation. If no one else wants to ask something, then I think I will close the question time. So Henri, thank you very much for your time. There's another comment coming in. Awesome, thank you a lot. So it seems like it was quite worth watching. And I guess you can share the presentation with us. The recording's gonna be in the ASQF Net. So as a member, you can see it again in case if you want to, like, I don't know, see something again and or get in more detail with that. And Henri is nice to share the presentation with us, so we can upload it there as well. So thank you very much, Henri.
Thank you, and I'll actually see what I do. I might fix the deck to the way it should be. But that's the problem with that.
Okay.
That we shared in company, that somebody goes in and steals your slide, and it actually steals it.
How mean is that? All
right.
right.
Yeah. Hey, thanks a lot for inviting me. It was really great to be here.
It's always nice to have you at our talks. So thanks, Henri, and looking forward for the fixed up presentation. And one more comment maybe for the audience. There's another nice presentation coming up at 11 o'clock. We have test data management. And test development in automation later on. So just have a look on our website in case you want to join there as well. So goodbye, guys, and thanks a lot to Henri.
Thank you.